name is NURIN ZAHIRAH binti AFANDI, AF180027.
Hi, my name is Izzah FAQIHAH binti Suhalil, AF180081.
Hi, I'm SITI KHODIJAH binti ABDUL HAMID, AF180104.
Hi, my name is KHAIRUNNIZA binti AHMAD, AF180042.
Hi, my name is IZZATI binti ZAILAN, AF180026.
Introduction. Compaction is the densification of soil by removal of air, which requires mechanical energy. The degree of compaction of the soil is measured in terms of its dry unit weight. When water is added to the soil during compaction, it acts as a softening agent on the soil particles. The soil particles slip over each other and move into a densely packed position. The laboratory tests generally used to obtain the maximum dry unit weight of compaction and the optimum moisture content is called the Proctor compaction test. Proctor compaction test used in establishing a relationship between moisture content and dry density for the soil under controlled conditions. The standard Proctor compaction test was first developed by Proctor 1933 for assessing compacted field, and from then it became a universal standard test. The procedure used to achieve the dry unit weight of a wedge passive is also an indicator test for the specification and field compaction.
Literature review. History of Proctor test. Proctor's interest in the geotechnical engineering started when he furthered his study at University of California, Berkeley. He was keen on the distribution of Sir Alex Campton and his idea on in situ conduct of natural clay. In middle 1930, Proctor successfully created the solution in determining the maximum density of soils. In 1958, modified Proctor test was developed as an ASTM standard. Number 2, relationship between soil compaction and moisture content. Soil is compacted within the mold at different water content by applying equal amount of compaction energy, standard Proctor energy. At low moisture content, the compaction become less effective and as a result, the dry unit weight is low too. As the result, the dry unit weight after compaction first increases as the moisture content increases. At the moisture content at which the utmost dry unit weight is attained is usually referred as the optimum moisture content. Modified Proctor test. With the development of heavy rollers and their use in field compaction, the standard Proctor test was modified to a better represent field condition. For conducting the modified Proctor test, the same mold is used with a volume of 944 cm cubic as in the case of the standard Proctor test. However, the soil is compacted 5 layers by a hammer that has a mass of 4.54 kg. The drop of hammer is 457 mm. The number of hammer blows for each layer is kept at 25 as in the case of the standard Proctor test.
Methodology. Firstly, equipment. First, cylindrical metal mold, internal dimension 105 mm diameter and 115 mm height. Secondly, metal rammer with 50 mm diameter, face weighing 205 kg, sliding freely in a tube which control the height of drop to 300 mm. Next, measuring cylinder, which is in 200 ml or 500 ml in plastic. Next, 20 mm BS sieve and reservoir, large metal tray, electronic balance, jacking apparatus for extracting compacted material from mold, then small tools like palette knife, steel straight edge, 300 mm long steel rule, scoop or garden trowel. Lastly, drying oven 105 to 110 degrees Celsius and other equipment for moisture content determination. During compaction, verify the mold, base plate, extension, collar and rammer to be used are those that conform to BS1377. The mold body is weighed to the nearest 1 gram, which is M1. The internal diameter in mm and length in mm in several places is measured and the mean of the dimension is calculated. Internal volume of the mold in mm cubic is calculated by using V equal to pi times 2 diameter squared and times 2 length over 4,000. The empty metal tray and 5 kg of air-dried soil sample that has passing through sieve number 4 is measured. The mold is placed assembly on solid base such as concrete floor. Loose soil is added so that after each sequence of compaction the mold will be 1/3 filled. Next, the soil is compacted by applying 27 blows of the rammers, dropping from the controlled height of the 300 mm. Ensure the rammer is properly in place before releasing. Repeat for the second and third layer that the final should not more than 6 mm above the mold body.
Result and discussion. Based on laboratory testing made by Professor Krishna Reddy from University Illinois Chicago of United States of America on compaction test by using Proctor test, the data are as below. There are 5 samples taken. From each sample, there are another 2 samples. From this data, we will get 2 different water content value from each sample. From that, we will calculate it to have the average. This is unit weight, dry unit weight, and zero air void unit weight table. Before that, we must change wet density and dry density to become a unit weight and dry unit weight by using a specific formula. This is a graph dry unit weight against water content. Zero air void curve is also given there. The zero air void curve and the dry unit weight against water content does not redundant. Thus, the graph is valid. From this graph, we will get optimum water content and also maximum dry unit weight.
Then we move to the discussion part. From the graph, we can get the optimum moisture content is at 14% and the maximum dry unit weight is 18 km per meter cube. Optimum moisture content and maximum dry unit density are useful in the stability of field problems like roads embankment, earthen dams, and airfield. Proctor compaction can increase 3 things, that is bearing capacity, shear strength, and density. And it also can decrease 3 things, that is voids, permeability, and settlement. In conclusion, compaction of soil is an important process to help achieving various physical properties for proper soil behavior under loading. For example, proper compaction of a highway embankment can decrease the probability of its settlement by increasing the shear strength of the soil, increasing the soil density, and reducing soil permeability. Thank you.